This is Algebra 2 at Trig, 7A.2, Explicit Formula, or we'll work with our sequence, primarily with the arithmetic. An arithmetic rule, we are going to create, so the explicit rule creates a sequence based off the position. So the position is what is the first term. We would plug in a 1 to figure out what that term would be. In this case here, what is the fifth term? We would need to be able to plug in a 5 to figure out what the fifth term would be. We can think about this as a graph also. So with the graph, we have domains and ranges. The domain is the position value, or we can also call it the number of terms. So what is the term value? The range are the actual results that we get. So the value of the term. So this would be our y value, also known as a of n. This would be your x value, also known as your n. So when we see an a of 5, that means the fifth term gives us an answer of 16. That can be written as an ordered pair, 5, 16. That is the n term, the a of n answer. That's your position, and that's the term. So we'll write out, using our formulas, write out our sequence. So a of 1, to figure out the first term, we should be plugging in a 1 into our formula for the letter n. So 2 times 1 plus 5, that gives us 2 plus 5, which is 7. A of 2, we would be plugging a 2 in for n. So 2 times 2 plus 5. That would be 4 plus 5. Gives us 9. And we can continue this pattern. You should be able to continue the pattern without looking up at the screen for each number. So we plug in a 3. We do a calculation, and you should get the answer of 11. So go ahead and try the number 4. Plug 4 in. You should get the answer of 13. And before I run out of room, I can still plug in the number 5. So if you notice here, the values are increasing by 2. The terms are increasing by 2. So the 2 that's in the formula, what we might call the slope position, if this was y equals mx plus b, the slope, how it's changing, is changing by 2 every time. We could consider our y-intercept to be when we plug in a 0, that would give us the 5 when n was 0. It's not your first term. The 5 is not your first term. Your first term is when you plug in a 1. So let's try letter B. F of 1, that means you plug in a 1 for the n, which means you have negative 2 to the 0 power. And we know every time you do a power of 0 to a number, we get the answer of 1. Two minus 1 means that we're going to be doing negative 2 to the first power, which is negative 2. And you should be able to continue without looking up at the screen so many times. So when you square negative 2, you should get 4. So you can notice how our terms are alternating between positive and negative each time, and they're doubling as they go. This would be considered exponential, where our first example was considered linear. So how are we going to figure out our sequence with this formula? What does the formula mean? When you're looking for your first term, that means you're going to plug a 1 in for each of the n's. So we get 1 over 1 plus 1. So that's 1 over 2. Then we get 2 over 2 plus 1. That's 2 over 3. Then 3 over 4. And 5 over 4. Apparently our final answer is the 4 over the 5, so it's 4 over 5. All right, here we're going to look at our formula. This creates a sequence. We'll look at the first several terms of the sequence. So again, we're going to look for our first term. So we plug in a 1. So that's 3 minus 1, which gives us 2. We can come over to our graph. Our first term, which is our x value, our first term is 1. And our result, our position, well, let me start over. The position is 1, and the term value is 2. When n is 2, our position is 2, our term's going to be 5. Our position is 3. Our term's going to be 8. And on our graph, we can fit one more. Got to be sure we plug in the correct value. We plug in 11. So for the fourth term, we're up at 11. So these points are the values that we're getting, the position and the term. There are no values in between the first term and the second term. So we would not connect these dots together. This is considered a discrete graph, not a continuous graph. We have the position of the first term. We have the position for our second term. But there's not a position for a term in between them. So we don't connect representing all the points in between. So when we look at this, this is following the pattern of y equals mx plus b. The terms are going up by 3 every time. That's the family, sorry. Gave that one away. The pattern, we are increasing by 3 because our slope of our rule, really your d value, the common difference, is 3. That's considered the slope. Then for the family, it would be linear because it's increasing by 3 every time. There's not a curve to it. It's definitely not quadratic. Now to think about the explicit rule for arithmetic sequence, the format is really just y equals mx plus b. The m is our common difference. And the n comma a of n, the position and its term, is just your xy value on a graph. The b term in your formula is not what your first term is. It's what your 0 term is. So here we had -1. That was not the first term. That's not what we got when we plugged in 1. It's what you get when you plug in 0. It's what you get on the y-axis. The slope of 3 would put you down here at -1. We're going to find our common difference, and this is going to be our slope. And we can pick any term, and that's going to be our x comma y value for our equation. We're going to use this to write the equation, and we're going to be sure to replace the y and the x with a of n and the n, since that's what's used for a sequence. So the nth term of an arithmetic sequence, with the first term being 8, think about this on a graph. The first term, position number 1, the term is 8. But if the common difference is 7, that means it goes up 7 and over 1. That means it came from down 7 backwards 1. We need to figure out where it's crossing down here. Our first term, that would be 1, is 8. Our common difference, which is considered our slope, is 7. So we can use y equals mx plus b and plug in our y value of 8 and our slope of 7 and our x value of 1, and we can solve for the b value. So 7 times 1 is 7. If we minus the 7 across, we're going to get 1 is our b value. So our rule is going to be a of n equals 7n plus 1. Because we got a positive 1 here, and we verified that on our graph, that 7 down from 1, 8 would be still in the positive zone. Here we're going to write a rule. Here's a sequence. Notice how it ends with ... That means it goes on forever. In this pattern, and it can continue. We want to know what the 12th term of this pattern would be. One way to do it is to figure out what the 5th is, then the 6th is, and then the 7th and 8th and 9th, and go all the way up to the 12th. But with this being algebra 2, we want to calculate it and jump right up to 12. So first we've got to figure out what this common difference is. So one way to do it is to take the 47 and minus the term before it, and we notice that that went up by 15. And you can check the steps by taking a term minus the one before it, and we keep getting 15. 77 minus the 62, that gives us 15. That means our common difference, which is also known as our slope, is 15. So we're going to take y equals mx plus b. We can take any term and its position. Most commonly, we can take 32. Our slope is going to be 15. 32 comes from the first position. What we don't know is what our b value is. And we can subtract the 15, which gives us 17, which means our rule is going to be a of n, 15n plus 17. And you should be able to test that. If you plug in 2 to your formula, 2 times 15 is 30, plus 17 more gives us 47. You should be able to test your answer to see if you got that. Now we're looking for a of 12. A of 12 is going to be 15 times 12 plus 17, which is 180 plus 17, which would be 197. Would be your 12th term. One term of an arithmetic sequence is a of 19 equals 48. That means the 19th term is the number 48. Our common difference is 3, which is telling us that is our slope is 3. This is our x and the y. So we're supposed to write a rule. So we have our point. What we don't know is where we would start this out at. So we're trying to find the b value. So we would subtract the 57, and that would give us negative 9. So our formula is going to be A of n equals 3n minus 9. So if you plugged in 19 into your formula, you should get the answer of 48. So 3 times 19 minus 9 should give us the answer of 48. You can test your answers. We're going to write a rule given two terms. When the given term creates two ordered pairs, known as x comma y, and uses them to find the slope, which is our common difference, d. We'll continue to write the rule for the sequence. So here we have two different positions and two different terms. So we could consider this to be 8 comma 21 and this to be 2797. So the first thing we want to figure out is what is our slope. We have a slope formula that's known as y2 minus y1 over x2 minus x1. That's considered the slope formula. We learned in Algebra 1. So 97 is a y term, minus our 21. 27 minus 8. So this would be 76 over 19. That's going to be 4. That is your m term. What we still don't know is what the b term would be. So we can take either point. I usually like to take the smaller numbers. So I'll take 21. My slope is 4. My x value is 8. I just don't know my b term. And if I subtract 32, that gives me negative 11. So my formula is going to be a of n equals my slope, we said was 4, n minus 11. All right, now the U try. Go ahead, pause the video, give the two U tries a shot, and then come back and see how you did. So one of the terms in our sequence is 8 comma 50. The eighth term, the eighth position, has a term of 50. The common difference is 0.25, so that would be our slope or our common difference. I prefer a fraction over a decimal. So if we think about using y equals mx plus b, we know our x and the y is 50, our slope is a fourth, our x is an 8, so that's going to become 2, and you subtract the 2 to get 48. So our rule is going to be a of n equals 1/4 n plus 48. You could write it n divided by 4 would be appropriate also. Now if we have two terms, we have the 5 comma 10 and we have the 30 comma 110. That means we have to use our slope formula. Subtract the y's, subtract the x's. So we get 100 over negative 20, which is negative 5. So that's our slope. We use 10 when our position is 5, and we're solving for b. Add the 25 across, we get 35. So our formula is going to have a slope of negative 5, n, and a positive 35.
Mr. Weber, it's not 50.
It's 5. It'd be 30 minus 5. Which would give you a slope of 0.5.
Got you, I see. So I have a 50 down here, but that's just a 5. So that's actually going to make this a 25, which is going to make this a positive 4. It's going to make this a positive 4, and make this a positive 20, and make this a negative 10, and make this a minus 10. We should test this. I obviously blew that, so let's test it. When you take our formula and we plug in the number 30, so 4 times 30 minus 10 should give us the answer of 210, or 110. And when we plug in the number 5 into our formula, minus 10, we should get the answer of 10. All right. We did it. All right, last one. Crazy word problem. What makes this different or difficult is the units. You've got to watch the units. Okay, Chuck, maybe Charlie Brown, deposits $500 into a savings account. He decides that he will then deposit the same amount each month into the account. He's not going to withdraw any for at least 5 years. So we're starting with $500. So at 0 months, we have $500. After 1 year, we're going to have $920. This is 1 year. How many months is that? That's 12 months. So at 12 months, after we've deposited some money, we're now going to have $920. What family of function best describes the situation? If we're increasing and decreasing by the same amount, that would be linear. If you're increasing by the same amount each month, that is a linear concept. All right, we'll write an explicit rule. We'll write a recursive rule. But before we actually do that, we need to figure out how much Chuck is depositing each month, because we need that for the rules. So if we look at our two ordered pairs, we can use that to create the slope, just like we did earlier. We took our ordered pairs and we used that to figure out the slope. So if we take the 920 and we subtract the 500, take the 12 and minus the 0, we get 420 divided by 12. Then 12 goes into 42 3 times, which is 36. That leaves us 6 left over, so it's got to be 35 because 12 goes into 65 times. So we're going to deposit $35 into the account each month. Now let's write an explicit rule. Well, the explicit rule, we have $35 every month, but what are we going to start at? We're starting at 500, but what's it going to be at 0? I guess that would be 500. Very good. The recursive, remember a recursive rule needs the first term, needs to know how much money is going to happen. And then from there, so in this case, this is a good explanation for this. It might make more sense to call this A of 0 because we haven't deposited any money yet. And in an orderly idea, after one deposit of $35, how much do you have? So sometimes you see the use of A of 0, and sometimes you see the use of A of 1. It really makes sense in a story problem than anything else. But that is our first term that we're starting with. And we are going to take that first term and we are going to add 35 to it every month. How much money will Chuck have after 5 years? So do we plug in a 5 for n? We need to plug in 5 times 12, which is 60 months. Remember, the units are all done by months. So 35 times 60 plus the original 500. $35 times 60 and the original 500 gives us 2,600. And what type of rule, is it going to be explicit or recursive, was more efficient to find this answer? Well, I obviously used the explicit formula. I plugged in the 60 right away. I did not take the 500 and figure out the first term and then the second term and then the third all the way up to the 60th, because you can't go straight to the 60th with recursive. I use the explicit rule by plugging in a 60.